Good evening, everybody. My name is Richard Parmee, and I've spent a distressingly long part of my life X-raying food, and that is the topic of my lecture this evening.
Ladies and gentlemen, welcome everyone to this, the fourth in our series of Darwin lectures for 2022, this year on the subject of food. It's a real pleasure to be here today, to see all of you here today in person, as we all grapple with the challenge of COVID, which unfortunately has the capacity to upset the best laid plans. Those of you who are regular attendees will have shrewdly noticed that I am not Mike Rands, the master of Darwin, who normally presides. Mike unfortunately contracted COVID a few days ago and is therefore isolating at home, but I'm sure he's watching the lecture remotely today, along with many others who are interested in today's topic. Mike, we send you our best wishes and wish you a full and very speedy recovery. I'm sure you'll be back here next week. My name is John Nilsson Wright, and along with my fellow Darwinians, Miguel Anya and TJ Young, I'm one of the organizers of this year's lecture, and it's my pleasure and privilege to stand in for the master. Over the last few weeks, we've heard from Sarah Bridle discussing the critical question of food and global climate change. In week 2, Andrew Knight gave us a fascinating exploration of a very specific and at first glance counterintuitive proposal, whether cats and dogs should go vegan. And then most recently last week, Sarah Mukherjee provided us with a wide-ranging analysis looking at the issue of food, power, and society by considering the role of farmers and consumers in the food industry. Today, consumers are again part of our discussion, but from a very specific perspective, the question of how best to ensure the safety of what we eat and what physics and technology and industrial innovation can do to help us eat with confidence. To explore this issue, we are fortunate to have a scientist and an entrepreneur, Richard Parmee, who works at that critical intersection between research and industry and is actively involved in applying science to improve our daily lives. Richard, like many of our speakers, is locally based. He studied for an MA and a PhD here in Cambridge. As an undergraduate, initially, he read natural sciences at Pembroke College before moving on to study electrical engineering. His career as a researcher and entrepreneur has involved work in a variety of fields, including image processing, precision measurement, statistical quality control, and the end-of-line process that is a key part of manufacturing. He also holds the William Pitt Fellowship at Pembroke College and is a board member of Cambridge Angels, which helps mentor and provide advice and investment research for research entrepreneurs seeking to translate innovative scientific ideas into successful business initiatives. In his early career, Richard's work was in the audio music business, and he made amplifiers, which involved working for some iconic rock bands such as Led Zeppelin, Genesis, and Deep Purple. And I'm particularly looking forward to discussing that with him over dinner. Later, his work focused on microprocessing, but this then quickly expanded to include visual and X-ray-based inspection systems. He now chairs the Cheney Group, an international group of companies that uses X-ray technology to support safety within the food industry. And it's that latest technology which provides the focus of his talk today. A talk which I imagine will provide insights into food safety and health, industrial production, and perhaps also touch on the psychology and behavior of consumers. So without further ado, Richard, the floor is yours. Thank you.
Good evening, everyone. Thank you, John, for that great introduction, and many thanks to the Masters and Fellows of Darwin College for the opportunity to reminisce and pass on a few anecdotes. I would like to take you through the fascinating journey that has been my life. So, we're talking here about food. Why is food important? Well, it's a basic need. If we follow the Maslow pyramid, it's the green bit at the bottom. It's the most important, the physiological need. but it's also about safety and trust. Food can have dramatic effects if something goes wrong. But it is also very much about the senses. We see a lot of food programs on TV nowadays. It's about the taste, it's about the smell, and it's also about the look. So it's an experience. Of course, it also forms the basis for health and can in itself create health issues. It's about desire, awareness, expectation, satisfaction. So there's an awful lot of things that are really wrapped up in food, and a lot of pressure on the ability to provide food to a particular standard. So why are X-rays relevant to food? Well, like all business ideas, it's just started as a concept. You know, how do we help the retailers? How do we help the supermarkets ensure that they provide good quality food, free from any defects or whatever? And how do the customers, the buyers, actually know that the food is good to eat? And actually, you know, from quite a few different angles, as we'll see, X-ray technology can help quite a lot there. So basically, this is in part a personal journey. I have an absolute conviction, by the way, that entrepreneurialism is a congenital abnormality. And, you know, there are a certain number of people who are actually born with this urge, this desire to do crazy things like start up businesses and so on. I started my first company around about 1 million years ago in an area, as John said, that was completely unrelated to food. That was while I was a postgraduate student here in the Department of Engineering. And it was a time before entrepreneurial aspirations became fashionable. It was a case of, oh, commerce, that's nasty, grubby stuff. We don't do that in Cambridge. But things moved on a lot from there. So completely by chance, after founding my second company some years later, I ended up working in the area of quality control. And through a series of enormous coincidences, I went on to develop X-ray imaging systems, specifically in the area of food production. I very much enjoyed Sarah's talk of last week, which resonated considerably with me. I recognize many of the similarities in the areas that I've experienced, such as the power of the supermarkets. This evening, I'll present what is primarily, I think, a technical and commercial perspective, rather than necessarily a strategic or philosophical view, although you will probably detect a few prejudices along the way. I think many people do not realize that X-ray technology is very widely deployed in the food industry. In fact, there is a niche area involving the use of ionizing radiation for sterilization to extend the lifetime of tomatoes and things like that, which is far better known than the area that I work in, which is the inspection applications. While there was initial concern about the effect that X-ray inspection could have on the food itself. Unlike its use for sterilization, the inspection of food involves radiation levels about 10 million times less than sterilization. In fact, the emissions from an X-ray inspection machine are actually, by law, substantially less than you would receive from flying a jet plane at 30,000 feet. Food is supplied mainly via supermarkets, who have enormous economic power. But very little of what the supermarkets sell is actually made by them. This is almost entirely produced by a series of food processing companies. The supermarkets, however, mandate the quality standards, and in many cases, the means by which these are achieved. The quality leader among the various chains is, in fact, an operation called Marks and Spencer, who have created the specification that is adopted by almost all members of the British Retail Consortium. And in turn, the BRC standards are now really recognized globally. Originally in the UK, there was a legal requirement that food processors and food manufacturers would have an obligation of due diligence, specifically to ensure that the food was good to eat. For a long time, the perception was that this responsibility could be discharged by placing a metal detector on the end of a production line. But this was predicated on the fact that metal detection was a practical and cost-effective technology, although, of course, it's limited to the detection of metal. The principle here being that the organizations should use the best technology available to meet their objectives. So this need spawned a whole series of initially British companies, because the driver was from the British retailers, who developed such equipment. Of course, it's easy to identify flaws in this approach. For example, many food products are packaged in steel cans or metallized plastic materials, which would render the metal detector more or less useless. Furthermore, metal detectors do not work particularly well when inspecting products that comprise of polar molecules such as fat, or products that contain salt. So foods such as meat and cheese cannot be efficiently inspected using metal detectors. Furthermore, metal detectors react differently to products at different temperatures. So many food products are frozen at temperatures down to minus 18 degrees C. And that said, the metal detection is cost-effective, and it's actually still the most widely used method of assuring food safety. Every year, in excess of 40,000 metal detectors are installed on equipment every year. So the story of X-ray in this context started in the early 80s. My own journey started with a design contract to develop an X-ray detector and then associated imaging electronics. In this case, the first application I did was actually nothing to do with food. It was checking the metallic webbing in car tires. The advantage of the application was it was relatively high-value product, and frankly, there was no other way of inspecting it. So, of course, once you've built a piece of equipment to inspect car tires, it's great fun to sort of take other objects and feed them through and see what the images look like, and which was exactly what we did. So how does X-ray work? Well, it's a fairly simple device. At the top, we have an X-ray generator, which squirts out X-rays. And then we have a conveyor with products going along it, and underneath we have a detector. And then we have a series of bits and pieces of electronics that result in a picture. So the principle is broadly similar to the type of X-ray machines that you see at an airport. Generally, as the product is passed through the conveyor, the image, in our case, will be automatically analyzed, and anything that's non-conformant will be physically ejected from the conveyor with a mechanism. The major differences when we compare baggage inspectors are the speed, the accuracy, and the degree of automation. A baggage inspection system will allow for inspecting perhaps one item every 3 seconds or 5 seconds. There will be an operator, and the operator will hopefully spot something like a gun. In contrast, we will be looking at items at a rate of anything from 200 per minute to 1,000 per minute, and needing to reliably spot something that's no more than a millimeter in size, and without any human intervention at all. So there's nothing like a challenge. X-ray is an ionizing radiation, shorter wavelength than ultraviolet, and of course we're all familiar with its use in diagnostic imaging. The X-ray sources that we use are at such a low level that there is no danger of irradiation at all. The food X-ray sector has generally borrowed techniques from other areas, such as medical imaging, and refined them for its own use. Normal applications use what we call transmission radiography. In other words, X-ray goes through the object picked up on a detector. And we're all familiar with that from having hospital X-rays. As an alternative, there is a technique called DEXA, dual energy X-ray absorptivity. And this was originally developed by the medics for bone densitometry for detecting osteoporosis and so on. One of the areas where DEXA is used in the food industry is in the detection of chicken bones. So chickens are designed to fly. The guy up there that designed the chicken intended it to fly. They're not particularly good at it anymore, but you know, that's a different issue. The result of this is that the bones are very light, and in some cases are hollow. So the relevance of DEXA to our type of inspection is quite clear. In this case, I can vouch for that what is euphemistically referred to as a chicken harvesting line is not the most pleasant place to work. The result of this is that an awful lot of resource has been put into automation, with the result that the point that the chicken arrives in a truck to the point it departs in a plastic tray or a package, it is barely touched by a human being. And that is why inspection technologies are really important. But more generally, the issue of staff is huge. I remember working once in a meat processing plant in South Carolina. The majority of the workforce actually consisted of inmates of the local penitentiary, and many were serving multiple life sentences. And they give these characters chainmail gloves and very sharp knives. I do remember one morning the local sheriff turning up, being dragged along by these wolfhounds that they use, and through the break area, a couple of operatives came racing through trying to make a break for it. But I would say, at least in the USA, there's a fairly widely available selection of people to fill such posts. So how did we start? When we first started experimenting with the use of X-rays for food products, it was inevitable that a number of the larger food companies would recognize that this was a technology that they had to understand. During those early times, which were more than 30 years ago, we were holding meetings and demonstrations of the equipment on an almost daily basis. And whilst everybody was incredibly interested in what we were doing, almost nobody was putting their hand on their checkbook and provide us with the revenue to fund our development. So it was quite tough for basically for a bootstrap company. Curiously, one of the first companies to make a commitment was actually in the pet food sector. They manufactured their product in a slurry, and they pumped this through a 6-inch diameter pipe. The X-ray images were absolutely fascinating, as there was all manner of stuff inside pet food. We were seeing clearly identifiable things, such as sheep's heads going through the pipe. And this became the start of a period of many false dawns, not to say disappointments. At the start of each year, we would think, this year is going to be the year. And at the beginning of the following year, it was, well, this year is going to be the year. However, you know, the hope rules eternal, and we just had to stick at it. But we got to understand a lot about what could be done and what couldn't be done, what was an easy job and what was a difficult job. As with many such situations, there was a trigger that gave the adoption of this technology a push. This was known as the Snowbrand affair. Snowbrand is a large Japanese dairy company manufacturing anything from ice cream to baby formula and so on. Back in 2000, it suffered quite a serious case of biological contamination. And as a result, many thousands of people got sick. The result of this was a criminal prosecution, and I'm sure you can appreciate that the culture of the Japanese salaryman found this absolutely horrific. Despite the fact that X-ray technology could do nothing to address the risk of biological contamination, the entire ecosystem became very risk-averse, and the deployment of X-ray technology absolutely skyrocketed within the Japanese market. And during that period, I had many, many trips to Japan. In the rest of the world, the market certainly developed, but at nowhere near as the same rate as Japan. But of course, it's interesting that one of the things that became apparent to us was the absolute sheer enormous volume in the food industry. And certainly in the last 25 years, the movement simply continued towards the production of more and more processed food. The cost of food is in the news a lot at the moment. Pressure to reduce the end-user cost while retaining the quality requires automation and ever faster production methods. Provides new challenges to the equipment manufacturers as well. There was a time, and I do believe Sarah mentioned this last week, where if you wanted potatoes, you would cook them and mash them. Nowadays, if you want mashed potatoes, you go to a supermarket and buy a tray of mashed potatoes. I think I can confidently say that there's very little likelihood that the majority of us will go back to peeling potatoes again. Along with these massive volumes is actually the monetary value of food. Think about a single 40-ton truck carrying meat. The retail value of the product in that truck will be almost £1 million just in a single truck. In fact, the global food industry is currently estimated to be worth $14 trillion per year. That's a lot of noughts. By way of an example, during this early period, I was working with a very large cheese company in the United States. The primary product of part of the plant was producing the so-called plastic cheese, you know, the cheese squares that we see. And the factory contained several production plants, each of which produced cheese in the form of a blanket. And it was a blanket that was probably 4 or 5 feet wide. They could do remarkable things with this blanket. They could make it go around corners by using origami techniques. Ultimately, these blankets were then split into 16 different lanes of cheese, and each lane was producing 600 slices per minute. I remember seeing the side of the factory, and there was a row of 50 loading docks with trucks, you know, entering and leaving the whole time. The person I was working with basically told me that every year the factory received 10,000 million pounds of milk, and they produced 800 million pounds of cheese, in each one in 3/4-ounce slices. Americans have always, by the way, had problems with metric units, I guess. But now, I'm a bit of a mental arithmetic nut, and I processed these numbers, and they were absolutely correct. But taking it on further, there was a second factory in the Midwest doing exactly the same. And I calculated that the number of cheese slices, if they went into cheeseburgers, would be sufficient for every man, woman, and child in the United States to have 250 cheeseburgers a year. Somebody there was getting 248 of mine. So there are numerous. We're currently working, by the way, in potato products. We're installing a series of things for looking at potato waffles and hash browns and all of this, right the way from the United States through to even Inner Mongolia at the moment. But actually, confectionery and bakery products are similarly produced at high rates. One of the more delightful applications I've worked on has been the production of a chocolate bar called a Kit Kat. Each production line produces between 4,000 and 8,000 Kit Kats every minute. And there are almost 90 production lines around the world. That's a lot of Kit Kats. I'll be talking a little bit more about that later. So, what is the primary reason for X-rays? Why are we bothering to X-ray all of this stuff? Well, the primary reason is to check that there are no foreign bodies there. As we've seen, we're basically following on where metal detectors picked up. And so the metal detectors are looking to identify and reject food with metallic contaminants, but X-ray can do so much more. It was simply a matter of time before it would be realized that metal detectors were no longer good enough to discharge the responsibilities of due diligence. An X-ray machine can not only detect metal, and actually considerably better than a metal detector can, but it can also detect glass, it can detect stone, it can detect bone, and many other dense contaminants. What is the mechanism by which we actually find these items? So basically it's down to the periodic table. Heavier atoms will absorb more X-rays. For example, anything made of steel, stainless steel, will contain iron atoms which will absorb more than the constituents of food, which would broadly be carbon, hydrogen, and oxygen. It's the same reason that, for example, that we can detect bones. Everybody knows bones have calcium in them, and they become quite visible in medical X-rays with a background of muscle. But if there's a difference between the atomic number of the atoms in the food and the contaminants, then these can be detected. I'm often asked if X-rays can detect plastics. If the plastics have a similar composition to the food, for example, polyethylene, polycarbonate, the answer is that generally they're undetectable. But many plastics have constituents which contain chlorination, for example. And the difference between the chlorine atom and the food matrix is sufficient to make it readily detectable. So one strategy for eliminating plastic foreign bodies is if you can identify the source and then make sure the source has got atoms which make them detectable. A good example of this is the dairy industry, where the product is transported generally through pipework. Now, pipes are connected together using O-rings. A conventional O-ring made of nitrile rubber will not be detectable by X-rays, whereas a chlorinated rubber, such as Viton, will be. And so the strategy is that the plants will replace all of their O-rings with X-ray detectable material. The differentiation between the atomic constituents of the contaminant is important. I don't know if I should flag up a warning to sensitive souls here, but it allows for the detection of bone through the calcium, glass through the sodium. But consider for a moment the manufacture of peanuts. Let's say dry roasted peanuts. Now, mice love peanuts. They get in among them and they eat a sufficient number so that they expire. As the remains dry out, the mouse's head is approximately the size of a peanut and the body drops off. This gives a bit of a problem because calcification of the skull is probably not dissimilar from the salting in the peanut. So a word of warning from somebody who knows, be on the lookout for extra crunchy peanuts. What drives this huge concern about foreign bodies in food? Well, in many instances, you purchase your food from supermarkets, which are extremely large companies. They need to take the complaints seriously, and this represents a major financial liability for their businesses. We'll talk more about what I call the psychology of complaint a little bit later. However, as I said earlier, very few supermarkets actually make their own food. This is the preserve of the food processing companies. These companies vie for the very, very large contracts. I mean, we're talking billions of pounds. You know, and the retailers there have the ability to track the source of a complaint. So, for example, you've all seen the codes on the underside of packages. They can track a complaint, a rejected, a returned product, back to an individual supplier, back to that supplier's factory, back to the production line, and right back to the date and time it was made. So there's two methods to minimize the occurrence of claims. The first is that the supermarkets will audit the food processors, including their administrative processes and their methods. And the second is that the supermarkets will impose fines on their suppliers. These fines can range anywhere from £100 per complaint up to, if the supplier doesn't take mitigating action, then it could be £1,000 or more. And this simply recompenses the supermarket for having to give away £25 worth of vouchers, but having essentially a manual process of having to investigate the complaint and do all the necessary paperwork that goes with it, as well as the potential risk of bad publicity. This is a significant motivation for the food processors to resolve their own problems. And nowadays, one of the main tools that they have in their armory to do this is our excellent X-ray technology. We do find some funny cultural issues popping up. We had a major project a few years ago where we were presented with a product where it was believed that there was a risk of lead. Now, lead is widely recognized as being quite undesirable to ingest, and certainly it represents a major area of concern for food companies. But think about a bunch of kids in the Midwest of the United States, in their pickup truck on a Saturday afternoon with their shotguns, and they go past a field of cows, and you know, they love nothing better than to let the shotgun off and just to see the cows jump. And whilst lead shot is very rarely used over here anymore, it's been largely replaced by stainless steel. It's still quite common in the States. So for one of our projects, we had very, very small pieces of lead analyzed, and the X-rays can actually detect tiny, tiny pieces of this. There is a perception amongst developed nations that emerging economies perhaps have lower quality standards than we would expect. But as a result of the insistence of processors and suppliers that buy material from developing countries, actually we're seeing quite a wide deployment of this type of X-ray technology in some very exotic and faraway places. So I'll talk more about that again in a moment. A further benefit of X-ray is you have a complete image of a product. This means that you can identify foreign bodies even if they're of the same material as the container. So it means that X-rays can identify metal contamination inside a steel can, and in the same way, you can detect a shard of glass inside a glass jar. So there's a certain very popular Mexican brand of beer where the beer is served with a piece of lime in the top, and it would be normal for the consumer to sort of basically swig it out of the bottle. If you can imagine that there's a glass shard in the bottom of that jar, the horrific consequence is that that shard of glass will be inside you before you realize that, and you can be sure that the beer producers are very aware of this problem. Of course, glass in glass becomes even more serious if you're considering baby food. And a lot of baby food is actually packaged in glass jars because of the sterility benefits. Feeding babies shards of glass can be a very emotive issue, actually. So we've got this massive industry, and the big problem is labor. So we're setting all of this against a background of increasing automation. Working in a food factory is not the most exciting career, and it's well known that in the industry that the whole sector has got huge staffing problems. In particular, in this country, we've seen great problems with recruiting staff, especially since Brexit. Prior to that, many food industry workers were from the eastern part of the European Union. And the absence of staff as a result of automation receives the last chance to catch any potentially dangerous manufacturing defects from getting out onto the production line and onto the market, and places a much greater emphasis on having the right inspection technologies. We're actually also seeing a similar situation in the harvesting process, as farms can no longer access labor with the skills necessary to pick fruit and vegetables. The introduction of harvesting robots requires the associated inspection. For example, imagine a field worker who's harvesting cauliflowers. As part of that process, he will put his hand into the leaves. He will be able to feel how large the floret of the supermarket, of the cauliflower is. If the items were harvested automatically, there would be no such awareness, and small cauliflowers would be cut, whereas the worker would leave them to grow bigger. So we're actually damaging the efficiency of food processing, the food production process. So anything that's growing in the field is likely to have unexpected creatures associated with them. For example, spinach is a well-known hiding place for all sorts of animals, in particular, rather small frogs. The bones of the frog are extremely thin and virtually undetectable against the background of the spinach leaves, even in an X-ray image. So the only part of the frog that we can realistically see is probably the head. And in a similar way, we've seen issues with small birds being packaged along with salad. In fact, some years ago, we have a subsidiary company in France that actually reanalyzes rejected product. And we made it onto French national TV with a a sparrow that was fully enclosed in a ball of spinach. It was our manager there was filmed poking the sparrow's beak, which was protruding from the ball of spinach. But we can do more than just find foreign bodies. Dense contamination is not the only sort of defect we see in food. For example, many food products are packaged in thermoform trays. There's a film lid over a seal area. The food materials in the seal area will be compressed and extruded, but they still leave the potential for a non-sterile channel. By using very low energy X-rays, it's possible to measure even the very thinnest amount of material. And the result of this is improved sterility and a longer shelf life, and of course less spoilage and waste in the product itself. The reduction of food waste is enormously important, and indeed an emotive issue nowadays. In addition to the reassurance provided by online automatic X-ray inspection, the technology also provides a means of reworking the products where there is a perceived risk. So if an event happens, such as the failure of a bearing in a machine, all the production is quarantined back to the point where they knew that the bearing was intact. And the quarantined product will be shipped out to a contract inspection company who will use a very similar X-ray machine to manually search through the entire batch until every single ball is accounted for. Once this has been accomplished, then of course the product can be signed off as good for sale. The point at which the food products are checked in a production line for the contaminants or the foreign bodies is often referred to as a critical control point. But this is not the only aspect of the product that needs checking. For example, many packages will display a weight, and it's the requirement of the various trading standards organizations to ensure that the actual weight of the product meets or exceeds what is on the label. There are numerous involved and arcane rules that define these requirements. Traditionally, this so-called check weighing has been accomplished with gravitational mechanisms, where the package passes over a short conveyor mounted onto a load cell. However, this is also an area where X-ray can help. The X-ray image of the package contains a series of pixels which can easily be converted into a weight by looking at the relative density of the pixels and aggregating them. So the process, which personally I prefer to refer to as mass measurement, the word weight tends to imply a relationship to gravity. The only problem we have is that in the case of X-rays can do an absolutely excellent job here, but such issues, there is a major one of the local trading standards officer that wants to come along with his big brass weight to check the accuracy of the load cell, and so brass weights are almost entirely opaque to X-rays. So we're working on them there. But there are some great examples where X-ray inspections can use algorithms to measure weight in different sections of a product. So imagine that we have a carton of apple pies. Let's say 5 out of the 6 apple pies have got a normal filling, which will probably be just a little bit more than the legal requirement. but the sixth apple pie is only half full. Now, that will be immediately apparent to a consumer, but to a check weigher weighing the overall contents of the pack, the overweights on the 5 will compensate for the underweight on the 6th. So, of course, this is where a conventional weighing mechanism would be unable to find the underfilled product. There are some even better examples where what we refer to as zone inspection really comes into its own. There is quite a popular dairy product known as a fruit corner. A large part of the container is filled with yogurt, and then a small zone is filled with fruit. And obviously a partial filling of the fruit section would be very noticeable. But this is particularly the case where actually you can get fruit corners where the additive is actually not fruit, it's something like a Rice Krispie. And the difference in the weight can be enormous. It would be completely impossible for a gravimetric check weigher to reject this. But in the case of the Xray, it's an excellent application. You can also get a variety of do-it-yourself kits. So this is an example of a dessert kit, which is widely sold in the United States. You have a couple of cookies, you have some frosting. There's actually even a little stick which is poking out from the cookies, which allows you to spread the frosting. And then you have some sprinkles. And on perhaps a 40-gram pack, there are probably only 1 gram of sprinkles. So in other words, the sprinkles are well within the tolerance of the other components. A nice application. So meal kits are becoming quite common over here. You can see very often the nonconformity in the product is not related to the foreign body, but it's still a product that doesn't meet expectations. For example, we have a meal kit which will have 4 or 5 items in it, perhaps protein, perhaps carbohydrate, some sauces, and so on. Now, if you buy such a meal kit and you take it home, of course, that's the first point at which you become aware that the sauce that you particularly like is actually missing from the pack. And so, again, the issue here is disappointment. Disappointment that is not necessarily easy to deal with rapidly, but will nonetheless give rise to an unsatisfied customer. We've got, again, a similar situation where, for example, kids are given a package, 8 slices of ham, 8 slices of cheese, 8 crackers. Oops, there's a cracker missing. It's the lightest, cheapest part of the product, and yet it precipitates the same degree of disappointment and complaint. Moving back up the value chain, if you operate a large restaurant group supplying beef burgers, you will specify that your food process suppliers provide you with meat that has a maximum fat level, typically 20%. It's ignoring the fact that actually food that's got more fat in tastes better, but you know, this is their explicit requirement. Your quality department will sample the product on arrival, and if the specification is not met, for example, you have an average of 21% fat, then you will have the right to return the entire delivery to the manufacturer. And as we've already seen, this can have an enormous monetary value. Because of the intrinsic relationship between the X-ray image and the density or the atomic constituents, it's possible for us to really quite accurately calculate the fat level in the meat being produced. This has two advantages. First of all, it prevents any risk of supplying out of specification material. But secondly, if your product is actually too good, you can mix in some lower quality material, perhaps some fatter material, and improve your profitability. And the accountants love that one. X-ray technology can be used to grade products. Products with small bones in, for example, fish products can be directed towards fish cakes or chicken nuggets, where the degree of processing can effectively remove the bone, whereas prime fillets, you really need them to be clear of such bones. This falls into the category where X-ray inspection actually saves money. I promised to return to Kit Kats, and in fact, this is a classic case of the X-ray being applied to save money. I don't know if anybody here has ever had a golden Kit Kat. That's one where the wafer has been left out, so they fill the mold up with chocolate. So you end up with a solid chocolate finger, which is absolutely wonderful. However, if you're the Kit Kat maker, you regard this as giveaway. A typical production line making Kit Kats will give away chocolate worth $700,000 to $800,000 a year. We make a wonderful machine that costs $300,000. So if you never get a golden Kit Kat again, you know who to blame. We don't only have to check for items that shouldn't be there, we sometimes have to confirm the presence of items. Additional items such as toys or so on are known as premiums. A nice example of this is a type of cake that's consumed in France, typically around Epiphany. It's known as a galette de roi. The galette is a marzipan-based cake, and it's divided into slices, and each member of your family has a slice. So inside the cake, there is a small porcelain doll called a fève. Whoever gets gets the fève in their slice gets to wear a golden crown you can see in the picture. Of course, it's important to ensure that there's at least one fève in the cake, but equally, it's a requirement to ensure there's only one. At a time of year when it's particularly important that there's no risk of unnecessarily precipitating family conflicts over who wears the crown. This is broadly reminiscent of the coin in the Christmas pudding that we used to have years ago. Galettes are produced each year from September to December. We have one customer who's been renting a system for 4 months every year for the last 15 years. Along with the detection of premiums, we also have a deoxidizer. So often food is packaged in a modified atmosphere to prevent degradation. So the package will be flushed with nitrogen or with carbon dioxide, to extend the shelf life. And to get the last little bit of oxygen out, there's a package of ferrous oxide. Of course, ferrous oxide would trigger a metal detector, but we can make an extremely good job of making sure it's present and there is only one. So in this area, there's been a great opportunity to install equipment all around the world in some really exotic places. The business of tuna fishing has become very fertile ground for X-ray inspection, especially as more tuna is becoming line caught as opposed to trawled, and the attendant risks of hooks in the fish. We have installations everywhere from American Samoa in the mid-Pacific through to recent installations in Madagascar and the Ivory Coast. We've even got one system installed in the Seychelles. There was a long queue of people in the company wanting to commission that one. But tropical islands are interesting symbiotic places. You have the luxury resort at one end of the island, and you have the fish factory at the other. One final example is a case where the X-ray inspection can identify when a manufacturing process is going wrong. A jam-filled donut will have the jam added into the cake through an array of needles. In the case of a ring donut, there will be 12 needles inserting it to inject the jam. If a needle is blocked, you will end up with a region where there is no jam. As this gets progressively worse with more and more needles becoming blocked, it will reach the point where the product's quality is substandard. So we can actually predict this, and we can arrange to get the needles unblocked so that we're not producing substandard food. So if a retail customer receives a substandard or contaminated product, they will, of course, complain to the retailer. The rise of social media has meant that the stories and examples of contaminants and other nonconformities spread very, very quickly. We have examples, for example, of customers, potential customers, showing us tweets where their customers are complaining about the problem and asking if there's anything we can do. So, in response to complaints, the retailer will investigate, and they will produce a series of vouchers, perhaps. For some people, this becomes a habit, which I do not recommend, because supermarkets do collaborate and maintain databases on serial complainers, and there's no pun intended there. It's also not a good idea to complain if you work in the contaminant detection industry. My own experience of this was when my family purchased a jar of jam with a piece of glass in it. Unfortunately, I was out of the country at the time, and they went ahead and complained to the supermarket. We got a nice letter back saying the retailer had investigated and claimed that the DNA of the glass was different from that in the product, which was a somewhat bizarre response, but it wasn't one I was ever going to pursue. So a good example would be a box of chocolates. You buy an expensive box of chocolates and you give it to somebody close to you. And you open it up and there's a missing chocolate. And the reaction is predictable. So basically, we're looking here at the psychology of the complaint. what makes people complain? So customers have an expectation. And we need to close the gap between that expectation and the degree of satisfaction that can be achieved. Complaints are based, of course, on statistics, but you also have to deal with different types of customers. The glass half full customer or the glass half empty customer. Many people will receive a disappointing product and they will do nothing, but they will not buy that product again. Some will actually make a complaint and look for the monetary benefit. So, and the presence of social media actually can support this, or it can ruin the business, depending on how it is used. Just a few closing thoughts. Food safety for the protection of customers from unpleasant contaminants or even injury is a really important thing. The possibility of ingesting glass or fish bones or other materials is really a significant concern. Secondly, manufacturing efficiency from continuous monitoring of the conformance of products will make sure that there is significantly reduced food waste and through the proper identification of non-conformant products. And finally, there's a financial efficiency, both in terms of the giveaway, such as in our Kit Kats, or the process of reducing customer complaints, such as in our apple pies. This efficiency must ultimately feed through into reduced food costs. So, where do we go next? Of course, artificial intelligence and machine learning is a new area. This is a topic I've been working on for the last 4 years, particularly with a view to finding a practical way of deploying this. The traditional way of dealing with machine learning is to produce a classification set of products or images to train the machine learning system. However, the image sets need to be quite large for a reliability of inspection. I could imagine, so we can get a large number, let's say 50,000 images of good product. But I could imagine that if I asked one of my food processing customers to produce me 50,000 reject products to train the system, it would be a very short and probably rather impolite conversation. So this needs to be about devising a system where the classification and training mechanisms can be essentially autonomous. These methods are by no means available for all applications, and in order for us to maintain the credibility of the method, then we have to choose the right products to deploy this. This is an example where actually we can. Cherries are depitted. This involves actually pushing the pit out of the cherry. It's very easy to get 50,000 reject cherries. They've all got the pits in, and then we pass them through the pitting machine. So this is one that we're currently working on at the moment to ensure that we have a continuous machine learning process. So basically, the conclusion is it's clear that X-ray inspection has an important role to play, both in assuring food, the safety of food that's supplied to consumers, and in the preservation of natural resources. I feel hugely privileged to be working in such an exciting area, and indeed an area in which a small Cambridge-based company can play a meaningful role in a global market. Thank you very much.
Thank you very much for a fascinating talk. You know, when we thought about the title of X-rays and food, one might have thought it would have been a very narrow talk, but I'm really struck. You know, you've not only told us about the diversity and scale of the challenges in the food industry, but you've also shown us in so many interesting ways, I think, how power is also a key element in this narrative, the relationship between supermarkets and food producers, food suppliers. You've also, I think, told us very interestingly about the important role of culture and all of those very vivid examples you gave us of different types of food challenges from particular countries. You know, we think of the food industry as a global phenomenon, but I was struck very much by the local dimension and how it drives the process of thinking about how to apply your technology and to stimulate entrepreneurship. And I think it's another indication about something that perhaps we haven't thought about, which is the role of the relationship between the entrepreneur and scientific research. You started your talk by recounting the comment when you were a student about commerce being nasty and grubby. I think you've shown us very vividly how essential it is, and also how reassuring the work, the valuable work that you do is for us when it comes to our food security and food safety. I take that as a very positive and, as I said, reassuring sign. Although I have to say, I'm going to be much more careful when I scrutinize my next pack of peanuts.
Yes.
Richard, thank you very much.
Thank you.